Oh, hello. Am I audible, visible? Just quickly let me know if everything is audible, visible, if we are good or not. I'm just meanwhile trying to set up and see if I am actually. Just quickly let me know that if we are audible, visible, and all that stuff. As a standard ritual, that how many questions you guys did in today's contest. Unfortunately, I was not able to come to today's contest because for the folks who hi Mohammad Nasir, hi भैया, third DP से कर सकते हैं क्या? Third. Yeah, we can do. But adding DP will just be a overkill, as in like it will not reduce the complexity of your problem. It will just be a parallel thread. Jatin, okay, where is hello bhaiya, please start quickly. Yeah, for sure, Jatin. We will start off super quickly. We'll start off. And okay, Mohammad Nasir comment has gone, no worries, cool. We will start off super quickly with all the problems, starting from the first problem itself. And just but meanwhile quickly let me know that how many questions you guys did and how was the contest for you. Fourth question, I'll say it was having very hard constraints. So no matter what, if you even know fourth question how that can be done, if still you were not able to solve it, then no worries, because it had super hard constraints. Maybe you are applying the correct thing, but still it might fail because of the constraint itself. But still we'll see that optimizations and stuff what we can do for question number fourth also. Cool. We'll start off with the first question. Minimum number game. Meanwhile, just quickly let me know how many questions you guys did and all that stuff. And yeah, for the folks who are regular, can we please smash that like baby. Minimum number game. You are given a zero index integer array called as nums of even length, and there, like, okay, we have nums of even length. And yeah, if audio and video still like anything get disturbed, just let me know. Nums of even length, and there is also an empty array ARR. Alice and Bob decide to play a game in which every round Alice and Bob will do one move, and the rules is that first Alice will play and he or she will get the minimum element, and then Bob will do the same and get the next minimum element. But when it is applying in the ARR, which means when they have to push element in ARR, first the Bob will push and then Alice will push ARR. For example, if we just take this array, so firstly Alice will grab the minimum element 2, then Bob will grab the minimum element, which is next minimum element, which is 3. Then let's say it is your ARR, then Bob will push in the element 3, and then Alice will push 2. Okay, now Alice chance to grab the element 2 and 3 are gone. Alice will now grab 4, Bob will now grab 5. Okay, now Bob will push in 5, Alice will push in 4, and the game will continue. So you see that always if we just say that this is one operation, this is one operation, and so on and so forth, this will be, and for sure they are saying that nums length is even, so for sure we will have all these as even length. So it is very obvious that Alice will choose the minimum number, so it will be 2. Then Bob will choose the next minimum number, which is 3. It's just that I am swapping, or basically saying that Bob will place his number first. Now the same way, Alice will choose the next minimum number, then Bob will choose the next minimum number. It's just that I am saying it will be swapped and placed, because Bob will place first, and the same way it will go on. So you see that this will be a sorted array. Again, brute force way, you can still do it in many other ways, but still indirectly it's a sorted array, just that the pair, the pair, which means these values will be swapped, and will be keep on going forward. And that's how what we can do in simple layman terms is, we have this array 2, 3, 4 and 5. We will simply sort this. Firstly we will just simply sort this, and after sorting we know that Alice and Bob will put his value first, so we will swap these values in pair. So I will swap this become a 3, 2, I will swap this become a 4, 5, and then ultimately I can return this particular value. Cool. Let's quickly see the code. It's pretty simple. So what we can do is we can simply initially sort. Let's zoom it up. We initially sort this array and then alternate, as you can see, like group of 2. We will just swap these nums of I minus 1 and nums of I. Just swap it because it is sorted and we know that Bob will place first, so just simply swap it and return our nums, and that's how we can simply get this solved in O of n log n. Cool. We'll go on to question number 2. So question number 2, and meanwhile we'll have a quick chat read. What the chat is saying. Chat. Hello Yogesh, hi bhai, hi Vamsi. Yeah bro, we watched your morning YouTube live stream. For the folks who don't know, by mistake, not even by mistake, but somehow my live stream was on, and I was shocked to see that how my live stream got on. And in that I was just yawning because I woke up pretty late, and you can also see my reaction in that live stream, although I got that as private, but I can show the reaction of that live stream. So this, okay, I'll show that in the end. Meanwhile, I'll show that for sure in the end. I'll just get that on the MacBook. So this is that reaction live stream. So I'll just show that, but yeah, in the end. So this is the reaction. This is a live stream which got on automatically, like not even by my choice. But cool. We'll go on to question number 2, which is maximum square area by removing the fence from a field. Now what this says is, and again, similar kind of question we have already seen in some of the previous contest. So that was it. Not exactly same, but similar. Okay, it was involving fences, remove, add fences and stuff. So basically it says that, okay, we have a large m-1 cross n-1 rectangular field where the corners are 1 cross 1 and m cross m. Just a rectangular field which we have, containing some horizontal and vertical fences, which means I will be giving some lines. That is the fences which I will be giving. Horizontal fences are from the coordinates h fence of I comma 1 to h fence of I comma n. So I will have some horizontal fences like these, right? And same way I will have some vertical fences. Okay, great. And the same way I will have some vertical fences. That is, they are given. Okay, some fences, like you can say horizontal fences, as you can see 2 and 3, it's a horizontal fence. This 2 is a vertical fence, and for sure the corner ones are not included, which means this is actually a boundary. This is a boundary and not a fence. This is a boundary and not a fence. So for sure these are not included. You can see from the constraints itself, right? Okay, cool, great. Now what I'm saying, or basically what I want is the maximum area of the square field that can be formed by removing some fences, possibly none. So I just want maximum square area. That is what I am looking for, right? Or -1 if it is impossible to say. Now, okay, and the area can be pretty large, so just modulo it with 19 plus 7. That's it. So ultimately, looking at our aim, maqsad. So maqsad nahi bhulna hai, right? So we have to get the area for a square. Square as in it should have equal length. Okay. Now my ultimate aim, which means my ultimate maqsad, is that I have to find a square. So I should go and find the height and the width should be same, right? Okay. Now I will try this height. And last time also, in the previous question also, we tried the height and we got, okay, earlier question was to get the maximum area of the rectangle, right? This is to get the maximum area for the square. For the square, I want to get this height first. For this height, I can ultimately get multiple heights. How? So if you just go and look back for this, if I ask you what all possible, again, forget this line for now, just let me know what all possible heights can be in this particular thing. So simply, that's as simple as that. One height can be of 1, other height can be of 6 minus 2, which is 4, other height can be of 6 minus 1, which is actually 5. So these three heights are possible, that is for sure, right? And if I ask you what are all the possible widths which are possible, you will say, bhaiya, it can be a 3, it can be a 3, and it can be a 6. These are all the widths possible. Now when I say, and ultimately these are only the widths possible. How will you achieve 6? By just removing this fence. How will you achieve 3? By keeping this fence. How will you achieve 3? By keeping this fence. Ultimately, if I ask you in this, what are all the possible heights? So you will say, okay, 1 is a possible height, 1 is a possible height, 1 is a possible height, or basically 2 is a possible height, 2 is a possible height, or basically 3 is a possible height, or I can just draw here, 3 is a possible height. These are all the possible heights which you can achieve by removing the fences, right? And ultimately I wanted the same thing. What are all the possible heights I can achieve? And I will just do the same. Okay, if I can achieve that same width any way whatsoever, if I can achieve the same width, then I will be able to make a square. Here you will see that I can achieve a height of 5, but I cannot achieve a width of 5. Okay, I can achieve a height of 1, but I cannot achieve a width of 1. I can achieve a height of 4, but I cannot achieve a height of 4. Sorry, width of 4. So for sure, square is not even possible here. Here in this case, I can achieve height of 2, 2, 1, and 3. Right? If I ask, I can achieve a width of 1, I can achieve a width of 1. Okay, I can achieve a width of 2. So I'll say, okay, width of 1, which means I can achieve the height and width as 1. That's one case. I can achieve the height and width as 2. Okay, and any more, okay, I cannot achieve a height and width as 3. So I wanted what? I wanted the maximum area. Maximum area will for sure come with maximum height into width, and maximum height into width is 2 into 2. So answer is 4, and that's how you will get the answer. Ultimately, so you saw that you will just try to get all the possible heights, you will try to get all the possible widths, and you will just say, okay, if I can get the equal height and width, I am good to go. And that is what you ultimately want. So now you will say, bhaiya, now to get all the possible heights, how will I get all the possible heights? As simple as that. You know, with this example itself, you know that you will have your fences, right? Just add an extra fence. Just add an extra fence, which is 1 and m. Add extra fence. With this, you can simply loop on. Okay, from 1, the first fence, this fence. Okay. From the 1, the first fence is 2, so height possible is actually 1. From this 1, next fence is 6, height possible is simply 5. Okay, cool. Now you will go on to the next fence. Okay, for the next fence again, go on to all the other fences. So it is kind of from one fence I am going to all the other fences and seeing what is the maximum possible height. Right? Or basically I'll just get all possible heights for sure, because I just wanted at least someone should match. Right? Someone should match, because I wanted square. I don't want a rectangle. I don't want the maximum possible height. I want all possible heights. It's just that I keep on checking if I can match with the width, at least width, because I want the square of maximum length. And if for sure if the width matches, I'll try to maximize it, keep on maximizing it, and that's how I can simply get this solved. So you know that you will just simply firstly place this fences, right, in the beginning and the end, and the same way you can just add your fences for the width 1 and n. Now when this is done, you will simply go and do a n square algorithm. As you can simply see here also, you have these two fences, right? You had these two fences. You will simply add a first fence and the last fence, and with this, okay, with this fence I'll go on to this, then from this fence I'll go on to this, from this fence I'll go on to this. So with this I'll get all possible heights between the fences. I'll get all possible heights between the fences, and that is what I was looking for also, right? All possible heights between the fences. Ultimately, when I have got that, I'll store that in some unordered map of possible heights, and I'll again go and try for all possible widths. If this possible width matches with the height which I have seen, which means, okay, my height and width are same, I can try to make a square. So I'll just try to maximize that matched width. Cool. And that is how, and you will see it will be actually going on to all the fences, which means you saw, right? It will be kind of looping. Okay, for the first fence, go on to all the other fences. For next fence, again go on to all the other fences, right? So it will be simply O of n square. N is the number of fences which you have. You saw you have m fences. You can have your fences dot length is actually 600, right? Maximum. So I can say I can have 600 fences, horizontal fences. So it will be simply 600 into 600 for horizontal fences, and again a 600 into 600 for vertical fences. Getting all the horizontal fences height, getting all the vertical fences height, and that's how you can simply get this solved. Cool. Let's quickly see that how we'll code this up. The complexity, as you can see, it is m square plus n square, right? Now if we want to see that how we can code this, exactly same, that initially we saw that horizontal and vertical fences will not include your first and last fence, right? But to bring out all possible heights, because you will, in your horizontal fence, you will only have this fence, but you want to get all possible heights, so you will have to include this first fence and the last fence to compare. Okay, from this first fence, okay, all other fences, what is the distance, what's the height? Okay, from this next fence, okay, all other fences distance, which is giving me the possible heights, right? So I did one thing exactly same. I just added in horizontal fence 1 and m starting in the last fence. In the vertical fences also I added 1 and n, which is starting in the ending fence. Now when this is done, I'll simply sort this to have the fences in the order itself. As you saw, the fences can be unordered, right? It can be unordered. So I just ordered the fences. Okay, fence with the index 1, then with the index 2, then with the index 6, and so on and so forth, which means I just ordered all these fences. Okay, I know the 1 is at the 2, the other is at the 6, the first one is at the 1, because as you saw in the beginning, I just inserted these 1 and 6 in my horizontal fence. So horizontal fence was only a 2, but then I added a 1 and the 6 horizontal fence also in my horizontal fence vector. So now I just simply sort it down, which is 1, 2 and 6. Why sorting down? Yeah, sorting is not required. It's just that I know one thing, that I can compare, okay, from 2 to 1, from 6 to 1. So I just have to subtract 2 minus 1, 6 minus 1. So I don't have to do a ABS. Although it's overkill, still you can just do a ABS and get the answer solved. But I just like this way, so I just solved that. I just sorted horizontal and vertical fences down, and with this sorting, my fences are now sorted in this order. Okay, now I have in 1, 2 and 6 order, I have in 1, 4 and 7 in the order itself. Now I just simply went on and got all the possible heights, basically all the possible lengths for horizontal fences. So I iterated on all combinations of horizontal fences from 0 to horizontal fences dot length, and from I plus 1 to horizontal fences dot length. With this, I will go and try for all possible horizontal fence combinations to get the height between them. I know this is the height between them, which is the length which I have represented, j minus I, because I for sure know that this is sorted. So this is always positive, because this is always sorted. So j minus I will always be positive. Else if you don't sort it, then you will have to just simply add a ABS function, which is the absolute function. So when this is done, you will say, okay, the possible length, it can be, like, just simply say, okay, this is the possible length which can be there. So I got all the possible horizontal lengths. Now I will similarly go and try for all possible widths. So I'll go and try for all possible vertical fences, which means getting all possible widths, width lengths. I'll just check, okay, if the current width length which I have got from the vertical fences, if it is also inside my horizontal fences, bro, I am good to say that, okay, my answer, basically one of my lengths can be this particular length, because it was also in horizontal, now it is also in vertical. So it was also in height, it is also in width, so it is one of the possible sides of square. So answer is the side of square. So it is one possible candidate of square. And also I mentioned that I want this candidate to maximize. I wanted this length, which means the side of square, I wanted it to maximize. So I'll just say, okay, This is the maximum possible side of square, and I'll try to maximize by just iterating on all possible widths, basically all possible widths for my vertical fences. Ultimately, even after trying so hard, which means even after trying all possible combinations of my vertical fences, if still the answer is -1, because I initialized with -1, if you just go and see, I initialized with -1. If it is still -1, bro, sorry, you cannot do anything, just simply return -1 itself. Else you can just simply multiply that, do a modulus, because multiplying huge values, because as you saw, the length can be 1e9, it can be 1e9, so 1e9 can be big. So just do a modulo with that value and simply get your square a, like side into side square, the modulus mod, and get the answer and return that answer. And that's how you can simply get this question solved. Cool. We'll have a quick chat read. If you have any doubts whatsoever, just quickly write down below, and then we'll go on to question number 3. Jatin, so late. Yeah, that's true. Firstly, in the morning, I was like, for 1 hour I was just in shock that how my live stream was even started without me even knowing that it started. I was legit in shock for entire 1 hour. Then I thought, okay, I need to figure out what happened, and then I just went on. I'll show. This was a live stream. I made this private, and then I went on to the entire live stream to just see that if I did do anything like bad or not. So here you will see that I woke up, and I woke up and I realized that I woke up late. I missed the contest. So here you will see, this is my reaction, that I missed the contest. The contest was already over. So I just went on and clicked the problems, and then I realized the contest was already over. So this was the reaction which I had when I got the contest. Contest was like, it was half an hour late even. I didn't even wake up like on time. But then around 1 hour later, I realized that my live stream was on. So that is first and third got 1009. That's great. Mohammed Nasir. Oh, for seconds, like if you got the third, that's super great, because third, I'll not say hard, but implementation wise it could have been tricky if you have not solved graph problems. But yeah, that's great. I didn't see the problems. I'm just here hoping you will explain the problems also. We explain the problems and then we go on to solutions. First and second only. That's great. Jatin, hello RS. Dead inside first only, easy hai, skip kar do. Yeah, that's true. Could only solve question number 1, got 4K rank, attempted number 2, it didn't pass all test cases. Yeah, like I'll say that we had already seen something of this sort of question number 2, and it was more or less to find the maximum area of the rectangle, if I'm not wrong. And this also, we had something similar. So yeah, it's just that you have fences, you have to only use the fences to get the answer. Can you name this similar question? I usually have a very bad memory of forgetting, but I just remember the snapshot. Okay, I've seen something like that. If someone remembers the last contest, it was exactly like the pictures were also exactly same pictures. If someone remembers that, can you please add that question? Cool. Us movement code and code milli. Okay, could only solve. See, that's okay. That's legit okay. See, firstly, everyone is different. Everyone has a different taste, different grasping power. Everyone is different. So please don't compare yourselves. Okay, my friend has been doing for 2 months, but he can solve third question faster. Maybe like, okay, he can solve the Leetcode faster, but he don't have that intellectual ability to solve the development, or basically to do other fields of development. I know that you might say, okay, bhaiya, but the companies will still ask Leetcode questions. What about the development stuff? But still, not everyone is good in everything. Don't worry. We can just try hard. Parallelly, keep on working on other things also. I'll just say that I have seen many people they try Leetcode a lot, but they become saturated and they are just stuck. So if you feel like that, okay, you have been trying a lot, but still you can do it, you like still you cannot do it, then okay, reduce the efforts which you are applying on Leetcode. Maybe it will actually increase your like efficiency, and also start parallelly focusing on other stuffs from where you can think that you can build your career. Like it's not important to do only Leetcode. Like it's finally so Aryan faced without the specs. But the second question was somewhat similar to the question few weeks back contest, but still not able to do it. Yeah, that's true, Om Kumar Jha. Please explain question 3, optimized code and logic. Sure, bro, I only able to solve first, and today was my third contest so far. No worries, the coding code. See, if it's a third contest, then it's super great that first. Hi, Sanak Das, if I'm pronouncing the name correct. It was contest 118, the similar question. Okay, so like if we can name the question itself also, question name was maximize area of square hole in the grid. Yep, maximize area of square hole in the grid. That is, you will see, see, we have to maximize this area. Exactly same. See, so it's just that you have to maximize this area of square hole, if I remember it correctly. Then oh, it has been also asked. Oh, that's a frequent question. How come it is asked by Swiggy? Cool, no worries. So you can just go and check this question later on. But cool. Don't spam, yeah. Cool, no worries. Don't spam. Thanks. Thank you, Sankhya. Yeah, please don't spam. Cool. We'll go on to question number 3rd, which is minimum cost to convert string once. Now it just says that, and for sure there's a follow-up, which is the question number 2. We'll see that also, but still that is more of a different follow-up, not the exact same follow-up. It just says that minimum cost to convert the string 1. Now you are given two zero indexed strings called as source and target. Now गर्मी लग रही है, पंखा चलाऊं क्या? एक मिनट, पंखा चलाता हूँ यार मेरा, बहुत ही गर्मी लग रही है, बहुत तेज. Okay, I'm back. Cool. So it feels a bit okay. So yeah. You are given a zero index strings called as source and target. So we have a source, we have a target. That's great. Now both are of length n. So okay, both have the same length, that is the length n. Now they all consist of lowercase English letters. That's it. So both have only lowercase English letters. That's it. Okay, now that is one thing. Okay, lowercase English letters. Now you are also given a zero index character array called as original and changed. Just saying that I can change this A to a B on with the cost given as the cost array. So I will also have the cost array. So I can change this A to B with this cost of 2. So if I just add this thing, so I will add this as a screenshot. Just to let you know that we are saying this as a feature. So now in this we are saying that we can change our A to a B with this cost of 2, which means A to B can be changed, but it's a cost of 2. Similarly I can change my B to a C with the cost of 5. Okay, B to C it can go, but with the cost of 5. C I can change to B with the cost of 5. C I can change to B with the cost of 5. Again, C I can change to E with the cost of 1. C I can change to E with the cost of 1. E I can change to B with the cost of 2. E I can change to B with the cost of 2. And ultimately D I can change to E with the cost of 20. D I can change to E with the cost of 20. So that is how what my changing looks like. Okay, I can change this with the cost of this. That's it. That's the question. What the question is saying to us. If we go back and see, now you start from the source So basically you are having this as source and this as target. Now you have to convert your source to the target. That is your ultimate aim. Okay, and following this ultimate aim, the one thing you want is to return the minimum cost to convert the source to target. So you will see that, okay, you have to convert your A to A. Oh, converting A to A, it's same. Don't worry, no conversion required. So I have a string source as A, B, C, D. My target looks like A, C, B, and E. So it's simple that I have to convert my A to A, B to C, C to B, and D to E. And again, I want minimum cost to convert the strings. Minimum cost. That's what I want. Which means, and ultimately, if I say that I have to convert A to A, so it is that, okay, cost to convert, let's say that I say the indexing is 0, 1, 2, and 3, right? Cost to convert index 0, cost to convert index 1, cost to convert index 2, cost to convert index 3. That is my ultimate answer, which is the cost required. I want to minimize this cost, right? A simple arithmetic formula says if you want to minimize this cost, for sure, if you want to minimize this cost, for sure, you will do one thing. The one thing is, what you can do is, if you want to minimize this cost, the ultimate thing which you can do is you can minimize everything on the left side. Then ultimately, if you minimize everything on the left side, you will minimize this cost, right? That is ultimately a simple arithmetic formula says. Ultimately, we have seen the question, what the question is saying. Now, which means I will have to find the cost to convert my A to A. Okay, that is my cost of 0. Convert my B to C, that is my cost of 1. Convert my C to B, that's a cost of 2. And convert my D to E, that's a cost of 3. That is the cost which I have, and I want to get all these costs, and that too, I want all these minimum cost. Which means to go from C to B, what is the minimum cost? So if I say, okay, I have something built, okay, from one node I can go to other node, and that would involve some cost, and I want to find the minimum cost to go from C to B, and I have multiple paths. I can go via E and then I can go, I can go via E and then I can go to B, or I can directly go to B. So you saw that I can have multiple paths to go from C to B, but I want to have the minimum cost to go from C to B. Now, with this word so far and this picture which we have drawn, it's just that we have just read the question and one example. That's it, what we have read so far. So with this, you can also easily imagine that our ultimate aim is for every index, I will have some source, I will have some target. For every index, I will have some source, I will have some target. From C, I have to reach to my B. It is my source, it is my target. I have to reach from C to B, getting the minimum cost. So it is as that saying, travel from C, which is the source, to your B, which is the target, having the minimum cost. So it is as that shortest distance from your source to the target. As you hear this word, shortest distance from your source to the target, just simply reading this line itself will say you can apply Dijkstras algorithm, where the cost is represented. Basically, you can just build the graph out of these 3 vectors, which we have already built in the very beginning. When this graph is built, ultimately, now you have just one thing to say. Now, okay, when my graph is built, I know that I will have to find, okay, what is the minimum cost to go from C to B, okay, what's the minimum cost to go from D to E, and so on and so forth. So I will just say, okay, my source is C, what's the minimum cost to go from C to B? Just travel in this graph and find out the minimum cost to go from C to, which means my source to target. So I will have my Dijkstras algorithm, simple, which will have a source, which will have a target, just saying me what is the minimum. It will simply return me the minimum distance, or basically the minimum cost to go from source to target. That is what my Dijkstras does. Okay, great. That is what it does. That's what also we want. what is the time complexity of this operation which we are planning to do? Okay, we know that we have to convert every character of my source to my target. Now, considering that source has a length of n, okay, source has a length of n, n for us is actually nothing but 1e5. Source has a length of n is nothing but 1e5. I will do, okay, I have to convert every character of source to target. Okay, so I have this length and I will go on to every character. I'll go on to every character, let's say as ch, and say, okay, apply Dijkstra, convert the source to target. Okay, apply Dijkstra and convert the source to target. So for every character in the entire source of length n, I will go and apply Dijkstras. Now, what is the complexity of Dijkstras? You have known, and we also know, it is E plus V log V. That is the complexity of Dijkstras algorithm. Now, bhaiya, what is E? What is V? What is V? E is nothing but number of edges. V is nothing but number of nodes. Now, you will see, okay, we have all alphabets, right? Alphabets if we have, so for sure our V will nothing but be 26. V is 26. E is the number of edges. How many edges can we have? Similarly, like as simple as that, one edge is from original to change with the cost of this, so it is one edge. So basically number of values in my original array will give me number of edges. So I'll just go and look, okay, my original and changed will have the length of 2000, so it is number of edges. So my number of edges, it is nothing but 2000. My n is nothing but, as you saw, it is nothing but 1e5. It is nothing but 1e5. So ultimately, if you go and apply Dijkstras for every of the source character, you will have a complexity of 2 into 1e8. That is something which will not work. For sure, it will not work. So you need to optimize it now. Again, that is a near brim to not working. So worst to worst case, 1e8 can work. Beyond this, there's a highly unlikely chance it will work. And again, 1e8 also very optimized 1e8 works, else it also doesn't work. So now you know one thing, okay, you have to optimize this. Now optimize this as in optimize what? You are doing one thing, you go on to every character, which will you have to go on to every character, right? Yeah, also, yeah, that is true. And you also, which means it is to go on to every character of your source. It is to just transform that source character to the target character. For Dijkstras, it is for that. Dijkstras. This is, you saw, it is actually nothing but 2 into 1e8. Well, like 1e3. Now, you can you just figure out or use something what is being done, what is being said. If you just see, everything revolves around characters, lowercase English alphabets, and they are just 26, right? So can't we use that facility? Okay, we know we have just 26 lowercase English letters. So in this string S, which is of length 1e5, I can in worst case have 26 English letters as in characters. So rather than applying my Dijkstras on all 1e5 characters, I will just say one thing, bro, let's leave it. Let's pre-compute and apply Dijkstras on all 26 characters only. On 26, which means I'll apply Dijkstras from A to Z. No matter what, I'll pre-compute and apply Dijkstras on only starting 26 characters. So I did one thing. No matter what, I did not even look at what my source and target is. Okay, no worries. I know one thing. My source and target will only have the English letters, right? So I will just apply Dijkstras on all of my A to Z characters. Now when I say Dijkstra, I'll just simply say one thing. Rather than source to target, apply Dijkstras from the source and keep on storing your answer, which means I will say, as I apply Dijkstras on my source, now the source will belong to characters from A to Z, right? As I apply Dijkstras from A, I will just say, okay, A to every character, what is the distance possible? By default, basically A to A, what is the distance? A to B, A to C, A to D, and so on and so forth up to A to Z. What is the cost, minimum cost? And I simply apply Dijkstras starting from A. And by default, I'll assign the infinity as the value. Infinity as the value. Infinity as the value. I'll assign infinity as the value. Infinity, infinity. Now A to A for sure. As I start on applying Dijkstras from A, you know, this is my actual graph. So let's have a quick try run. If I apply Dijkstras from A, what will happen? Okay, I'll apply Dijkstras from A to A. A to A, okay, same node, 0. Then I will go on, okay, for A, my neighbors is B. From A, my neighbors is B. So in my priority queue, I'll just push in what? I'll push in the distance, which is nothing but from A, I am coming to B. Its distance was 0. This cost is 2. So for B, I will have in my priority queue a distance of 2 and the character is B. Okay, right now I only have one node in my priority queue. It's a simple Dijkstras algorithm which I am applying starting from node A, or basically character A. Now, okay, that is great, that is done. I'll simply go and say, okay, then I'll just simply pick off the top element having the minimum weight, minimum distance from my priority queue. I'll get the 2 for B. Okay, for B the distance is 2. Okay, cool. Now from B I can go to C. From B I cannot go to anywhere, so I'll just say, okay, from B I can go to C. So for C the distance is nothing but 7. 2 plus 5, 7. Okay, that is great. So when I will just say it is the only element in the priority queue, simply remove it and mark, okay, for C the distance is 7. And then from C I can go to E. Okay, from C I can go to E. From C I can go to B, but B is already visited with a smaller value, so don't visit that for sure. Then from C I can simply go to E. Okay, so from C I can simply go to E. I'll just say, bro, simply your E will have a distance of 8. Okay, because for C the distance was 7, so for 2 up till E the distance will be 8. Okay, the distance will be 8 for E. Okay, cool. Then from E I can go to B with the distance of 8 plus 2, but the B is already having a lesser distance, so don't go to it. Now from E I cannot go anywhere else, so that will be my answer. So from A the distances to other nodes will look like 0, 2, 7, infinity, 8, infinity, 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 infinity up till infinity. So with this Dijkstras that we did on the node A, I'll do the same Dijkstras for all the nodes up till Z. So what will happen with this pre-computation? I will do Dijkstras on all the characters from A to Z, and that will be nothing but my simple nodes, which is nothing but E log 26. Right? E plus V log 26, but that is constant, so I can just simply say in multiplied by E. That is the pre-computation which I did for my all the nodes. Now with this pre-computation I have, which is 26 into E. E is nothing but 2 into 1E 3. With this pre-computation, that is for sure easily possible. With this pre-computation I have got the entire map. You can see, yes, you can just build the map from every node to every possible other character. Okay, from A to other nodes. So I have 26 nodes in the left side and other 26 nodes. So I will have simply a map saying what is the distance. I will simply have a map, or basically unordered map for your language, hash table, saying from this node, this source node to this target node or this target character, what is the possible distance. If it is having a distance, it can be infinity or some distance. That is it. Now when this pre-computation is done, so I will have all pairs for all 26 to 26 character. I will have all pairs. I will have entire everything in my map saying what is the shortest possible distance. Now I will go on back to my question and will ask, bro, A to A. I will ask not my Dijkstras, I'll ask my map which I have built. Bro, what is the shortest distance? My map will say, bro, it is infinity. Infinity, which means it is not even possible to reach. If it is a case, my answer will return infinity, so I have to go and return a -1. Which is, it is not even possible to convert your source character to the target character. It is not even possible to convert that source character to target character. It is not even possible to convert that source character to target character. Simply return a -1. If it is possible, then I know that it is storing the minimum distance. How? Because it is stored with the help of Dijkstras, which stores only the minimum distance. So I just stored the minimum distance with the help of Dijkstras, and with this I can just simply go and say that for every character, go ask your map what is the minimum distance from the source to this target node or target character, and get that minimum distance. If that distance is infinity, return a -1. If not, then simply add that distance value in your answer, and that will be the minimum distance. And for every character, I will have this minimum cost or the minimum distance, and I'll simply add this up to get the ultimate minimum cost. So it involves greedy, which means to get the final minimum cost, you are individually minimizing every of them as minimum cost. And to get the shortest path of the minimum cost from one node to every other node, or basically from one node to any other node, we simply use Dijkstras. You can also use BFS, but Dijkstras is a standard algorithm for users to actually solve it. Cool. So ultimately, you see that the time complexity for this is nothing but for every 26 characters, you did a E plus V log V, which is E plus 26 log 26 constant gone 26 into E plus, when this pre-computation is done, you will have a map containing 26 into 26, which means all possible combinations from source node to target node. And when this portion is done, you can now go on to all of your n characters, or basically n source to target, and this will be your ultimate time complexity of your answer. Space, nothing but it will be 26 into 26. If you are using a map, it will be lesser. It will just have the connections to those specific nodes only, but that will be your space and time complexity. Cool. Why I erased it, I can have it. Cool. Now, any doubts whatsoever in this question, in this approach, just quickly let me know. But you saw that everything was sequential. Firstly, we saw minimum cost. How to get the minimum cost? Minimum cost we can get if individually the cost we have to minimize. Now, individual cost to minimize, we know that, okay, from one node we have to search what is the minimum cost to reach to its target node. From this, what is the minimum cost to reach to its target node, which means source to target. What is the minimum cost to reach from, like start from source and reach to target? What is the minimum cost? Now, this is nothing but saying, okay, find the shortest distance, or basically the shortest cost, or the minimum cost to go from source to target. And simply when we hear these words, we know we have to apply Dijkstras. So one thing we saw that we will apply Dijkstras. Now then we realized if we go and apply Dijkstras on every of those n characters, then it will be n into E log V, which is very much. So we thought, okay, let's do some pre-computation. Now for pre-computation, I got to know one thing, okay, every of these characters are English alphabets. So for sure, when these are only English alphabets, which means these are only English alphabets, so I can do a pre-computation on all of these A to Z characters, and we'll apply Dijkstras on all A to Z characters. So it will be nothing but 26 into E log V. So applying Dijkstras on all 26 characters, then when things are pre-computed, then I can ultimately go and traverse on my source string to get it converted in my target string. And source to target conversion, character conversion will be stored in my unordered map, or basically a hash table. Cool. And that's how you can simply get this solved. Cool. We'll quickly have the code for this. If any doubts whatsoever, just quickly let me know. If any doubts, just quickly let me know. Can you solve third version using DP? I did using DP, but was giving a runtime error for some test cases. Then I solved using graph algorithm. If you want to do third question with DP without using graph, DP, I don't think DP will. You have to any of the algorithm to get the shortest distance. DP cannot find the shortest distance for you. You can apply DP plus graph, that I agree, but you will have to use graph to actually get the shortest distance. That is for sure. Cool. I And can you, okay, Aryan, after problem discussion, please can you play some multi-gamer games with our subscribers? It will be more great and happy for us. Multi-gamer games, how, like, that is a great idea. Quickly let me know that how we can play this, and like Vamsi, that's a great idea, but how we can play this and what are these multi-gamer games? Like, I'm not a game, like I did not game for quite a long time. I know some multi-gamer games like Scribble, but for that you guys need to be participating in that, and that would be great if you can participate. But yeah, I use Dijkstras in question 3, but I think it is not the optimal. You said that we can use some other algo in case of finding the minimum distance from manned source to many destinations. Yeah, we can simply use a BFS also. It's just that we will store a array called as the distance array I can store. So I can just also use BFS, but again that is not the most optimal approach to go about to solve the shortest distance problem, because it will unnecessarily go on to multiple nodes again and again, which is not, like, kind of, in terms you can say, okay, it is just querying and traversing all the edges, but it can traverse multiple edges again. Thus I'll say, and for sure you can also do this via BFS, but I'll not recommend using BFS for single source shortest path problems. But still people do it. Even though my solution is accepted, I think mine is not optimal. What was your, like, complexity wise, Satvik? Can you share the graph code for which you were written for the third question, Mohammad Nasir? But how we cannot share long chat here, Nitish Khanna? You can just probably paste the ID on link, maybe. Dada, today in the first of me to try the contest, but I don't solve any question. Why? What should I do? Please tell me. Satyajit, I'll say, like, but today in the first of me to try contest, but I don't solve any questions. See, if you ask, like, if you could not solve the first question itself, then I'll say we need some bit of practice for sure. And when I say practice, it's just that, okay, you saw the problem statement, you saw the solution, you got the solution. Now go and simply try coding by yourself at least. Logic is something which we can remember, but let's say like when I wrote this code down, for the question number 3, I did a very silly mistake of pushing back. Like, I'll explain the code, but the small mistake which I did was pushing back this changed rather than this changed. I pushed back the target, and I was just wondering why I was getting the runtime error, and I was getting it. I was so confused, and it took me around 1.5 hours to just see, okay, this was changed and this was the only issue which I was having. So debugging your code helps you. Again, logic thinking will come only by practicing or seeing more questions. So I'll just say, even if you're not able to solve any question, just try to understand the solution which I am giving. Let's say if you are able to solve only 1 and 2, there's a high chance fourth one you might not be able to understand, or if even you are able to understand, you might not be able to solve it even in the future. But still, you will get an idea, something from that fourth question. So I highly recommend just watch that fourth question too, right? Cool. We'll go, no, not BFS. You named some other algo in the previous videos. Yeah, there are multiple. See, if you want to find the shortest distance, so we have Floyd Warshall. So it will just say 26 into 26. So for all those characters, you can simply go and find. Again, for this question, Floyd Warshall, you can also apply Floyd Warshall for this. So what that would have done to your question will be, it is nothing but saying, okay, from your source node to target node, you can just try for all possible node combination. So currently, if you say that, okay, your time complexity right now is this into, what was this, 2000, right? So this would have been the complexity for your Dijkstras, which is 26 for all the characters. You try on for all possible values, which is e log v. and now into log this value, which is 26, that will be pretty small, so I just ignored that meanwhile. But if you are using Floyd Warshall, then what would have happened was that you will be doing 26 into 26 into 26, right? Which is, if I say, okay, 26 into 26, it is 626, which is actually less than 2000, right? So if you use Floyd Warshall instead of Dijkstras for this entire nodes, but the only change which you have to do for Floyd Warshall is, okay, like for sure you can optimize it, but that is not a good optimization. Basically, that's not a necessary optimization. It will use more space, but yeah, you can still do it if in the interview it is asked. So you know that you have 26 nodes here, right? So firstly, you will have to go, okay, I'll just do escape. Yeah, so you will have to go and just get the, see, I'm saying I have 2000 edges, right? In the verse 2, I'm saying I have 2000 edges. That's what I'm saying. But if you go and look back, if you have English alphabets from A, you can have at max 25 other characters. So from A, you can go and make edges to other 25 characters. So in worst case, I can have 26 into 26 edges only. These are the distinct edges which I can have. If I'm saying my original to changed is this cost, for sure multiple, let's say here B to C is a cost of 5. Again, you will see that B to C with a cost of, let's say, 4 would be repeating, because maximum number of distinct edges which you can have, considering you only have English alphabets, are just 26 into 26, which is actually, which we saw, it is 26 into 26 is nothing but 676 edges. That's the maximum edges, while you are given that in the worst case you can have 2k edges. So 2k edges are actually less. 2k edges are actually less, right? Sorry, 2k edges are actually more. So for sure, many edges which would be repeating edges having a different cost maybe. So you just have to minimize this cost. So you can for sure use our Floyd Warshall to get it in the lesser time complexity. So right now you saw it was the actual complexity which you saw was 26 into E log 26. Let's remain it as a constant, plus n was the complexity, right? Now if I just go and ask you 26 into 2000, it is 5 into, let's say 5 into 1e4, it is 5 into 1e4. Still this is 1 into 1e5, which is more. So no matter if you optimize this from 5 into 1e4 to actually 26 into or we saw what was the value, which is 26 into 26 into 26, which is 2 into 1e4. Let's say you optimize this from 5 into 1e4 to 2 into 1e4, still this will for sure be there, which has the upper hand, and thus your overall time complexity will for sure be O of n itself, right? Although you can optimize this from 5 into 1e4 to this value, which is 2 into 1e4, but that is just a like extra part which will actually also encounter some extra space. Cool. Cool. I hope that Satvik I was able to solve. Okay, some other I'll go maybe Warshall. Yeah, that is for Warshall, which we actually use in the fourth question, which is required. Cool. Cool. We'll quickly see the code, how the code looks like, and then we'll just see. So in the beginning, we just have this minimum cost function. I just iterated on all of my original vector. See, my original vector is this vector. So I have to go and build my graph out of from original to changed. I will have this as the cost, right? And yeah, Satvik, like for this Floyd Warshall, it will be used in question number 3 for sure, because we won't be able to apply Dijkstras in question number 4th. So I am just building my graph from this original to changed with this cost, right? So I just do one thing. I just went on and build my graph from this original, right, to changed. Now you saw that from this original to changed, I need to also keep track of the minimum cost. As I showed you, I will have a map, right, just saying that from this source to this target, what is the cost, right? Or you can see the distance of cost, same thing. So to make the map, so I'm making this map, which is the conversion cost, which means from source to target, if I convert, what is the cost required? Now one way is that you have to make a pair. Either you can do, okay, you can make a pair of character to character, and then, okay, what is the conversion cost? But if you use this pair as the key, then you have to convert your unordered map to a map, because unordered map does not work on complex data structures as the key. So what I did was I converted this pair of character comma character to actually a string, so that I can use my unordered map. And that's a conversion which we have seen in the yesterday's to yesterday's easy question of Leetcode daily content, like Leetcode daily problem, yesterday's to yesterday's easy problem. We have seen that we convert our pair of int comma int, or basically pair of character comma character, to actually a string, so as to use an unordered map for it, which has a lesser time complexity. So I just did the same thing. I have this particular function which will get two characters, and it will convert that character, separating with a delimiter. It will convert that two characters into something as, okay, if let's say I get the character as A and I have, okay, other characters is actually C. So I'm just saying C, A to C is nothing but, I was saying, okay, it's a pair of character, and the cost is, let's say, for them, the cost is nothing but COST, cost. So I'm converting this to a value as, I'll say, okay, A comma C is actually a string, and its value is nothing but this cost. So rather than having a pair, rather than having a pair of A comma C, I'll just say I have a string A comma C, and that is its cost. So this function will just convert two characters separated with a delimiter. You can just put any delimiter, whatsoever you want. Just don't use the characters of the string. Just don't use the character which is from A to Z, else it will interfere with your original and changed. Else you can use any character whatsoever you want. So with this, what you will have, okay, you will have a string called as source target, just this string A comma C. Now you can just simply return that string. That's a function which I made. That's not required. You can just either use a map also, it will still work. Now if we go back, so in the very beginning we had to build a graph out of it. So I build a graph from this as my original node. I know that I will go on to this changed of I with this specific cost. A simple graph which we make, okay, from this character, I have a vector of pair of character comma LL. Vector, multiple neighbors I can have, character as the target character, cost for that specific edge. That's a simple graph which we make, considering we have weighted edges. Okay, these two things are done for us. Coming on back, we will have nothing but our conversion cost, because conversion cost in the very beginning itself, I can just update that to the cost of I, right? Or you can also write this as conversion cost from the source target. You can just say a minimum of this existing conversion cost, but then if you initialize this initially, so it will be a 0. So either say if it is not able, you have not founded it. If you have founded it, just minimize it, or else you can just also minimize it while doing the Dijkstras anyway whatsoever. So with this, you will see that you have minimized your this value, which is, or basically you have just built the graph and populated your map. This map population is not much necessary, because Dijkstras will handle it separately. Dijkstras will do it and populate the minimum values only in your map. Now comes the interesting part. I'll go on to all the 26 characters and will perform the Dijkstras on top of it. Single source, shortest path. So S1 from A to Z. Now Dijkstras is the simple standard code of Dijkstras. Simple standard code. Simply using a priority queue, which is the min heap, right? By default it's a max heap, but I want the min heap, my distance and my source. Then I'll just say, okay, get the minimum distance. This distance array can actually is useful to either you can take the distance array or you can also take the visited array. Anyway, whatsoever array you want to take, you can take that array. Now you will start off with this distance array and you will say, okay, while your priority use, it's a simple Dijkstras which we have seen a lot of times. Simply getting the priority queue, simply getting the top element of the priority queue, and then getting the top node and the distance to that node. It's a distance to that specific node, which is a node which we have seen above. If this distance is actually already less than what we have seen, if this distance which we have got, but the distance which we have already seen for that specific node, if it's already less, so don't go into deep, just simply continue. But if this distance is less, okay, I'm getting a lesser distance, which is what I want from the priority queue. So I'll just update the distance and I'll update the same distance in my conversion cost map, which is ultimately the map which I'm going to be using to populate, to convert from my source, to convert my source to target. This conversion cost map I will be using, right? Cool. And then I'll simply go on to all of my neighbors. So I'll go on to all of my neighbors. This is a child pair, going to all the neighbors, just checking if that is not visited. And how to know it is not visited? If its distance is actually long max, which is the by default value. If it is long max, so which means it is not visited, then you can simply go and visit that specific node and say, okay, just push that in the priority queue, the current distance plus the distance from the node to this child pair. This is the distance, which is child pair dot second. How we do in a Dijkstras. The distance is the distance up till the node, and this child pair dot second is the distance from node to this child pair, to this child. So this is the distance from the source node to this child, and ultimately adding like the child itself. And by this entire loop, you will have the Dijkstras from your source, and for sure you will have populated your source to every other node, every other possible node. You will have populated this source to every other possible node which you have. Distance is done. Now ultimately, when I have called Dijkstras, I'll come back on my answer and I'll just say, simply say, go on to all the source nodes and simply get, okay, for this source of I to this target, I'll just firstly convert that to a string, and then I'll just check in my map. If I have that string, then it's good. If I don't have that string, simply return the -1. In my conversion cost map, I don't have that string, which means I don't have the distance between that that basically that source to target. I don't have that distance. I don't have any minimum cost. So simply return a -1. Else, if I have the minimum cost, simply add in your answer the minimum cost which is required and simply return that minimum cost. And that's how you can simply get this question solved. Cool. We'll quickly have a chat read. Any doubts whatsoever you have in any point, you can just quickly ask. And then we'll go on to question number 4, which is actually a very tricky question. And even if you understand that, if you even implement it, maybe it will solve, maybe it will not. Because like although I'll just show you that because its time complexity is just on the brim, like just on the brim. Cool. No, okay, yeah, third code with path third, yeah, cleared. That's great. Today's deep was exceptionally tough in my opinion. Yeah, that is true. Yeah, that is true. I'll for sure say today's deep was actually very hard. Cool. If you don't have any doubts, we'll go on to question number D. I see that we have a very less watching today, maybe in the evening. Not sure if it's actually the good time to have the stream or you want the stream in the morning itself, but yeah, in the morning I was just shocked about the live stream which got started. But cool, we'll go on to question number 4th, and with this question we can actually see and figure out that how we can solve this. Again, That's a great question. Cool. So for question number 4, exactly the same stuff. It's just that rather than converging, okay, the exact same stuff which you have to do, convert my source to my target. It is my ultimate aim. It's just that with a slight change, basically a big change, I should say. A slight change which we have to do is now the conversion will not be character wise, which means I am not saying I will convert every character of source to target, because if you go and look on the original to the changed array, I'll just quickly paste this particular portion. Let's paste this entire thing again. So if we have this entire thing, so it is just ultimately saying, and yeah, Anupam or Satvik, if Satvik, Anupam, Parth, code with Parth, Satyajit, Mohammad Nasir, Nitesh, Vamsi. If you have any doubts, code and code. If you have any doubts whatsoever, you can just write that down below. Cool. So let's copy this also. So now let's come back. So now rather than converting the characters, I have to go and transform. Basically, rather than having a conversion from a character to a character, I have the conversion from a string to another string, okay, with a specific cost which is given to us, okay. So you will see that now I will have strings rather than characters, but there is a slight change of what we can perform, okay. We have some string conversions, but if I'm saying I am using a source of A to B or to a source of C to D. I am converting some specific sub array which is A to B. I'm converting this to some target array and converting this C to D to some target array. So it should be disjoint. If not, it should be same. Now you will be confused what I'm saying. We will see by example itself, which means if I just say my source as A, B, C, D, E, F, G, H, and my target as nothing but A, C, okay, A, C, D, E, E, G, H, H, G, H, H, right? Now I'll just quickly copy this up for future use. So we are just saying one thing, that if I am converting this string, if let's say I'm converting this string to this particular portion, and for sure I can see that we can only and only convert if this is a 3 length, it's also a 3 length, right? You can see the lengths are same, right? So length will not change. Length in meanwhile is not changing. It is not the possible, okay, length of 3 to a length of 3. Now maybe this is also here, let's say from here to actually here. So you see, okay, the length will remain constant. It will be some, let's say from, so let's say this CD would have been here also, and then I would have some other length. So it will always be same. So length is not increasing, it's just changing the characters. Length is always same, okay, length is always same. Now I'm saying if I convert this specific length, this starting thing to a 4, now for the next conversion, now okay, if it is possible to convert, for the next conversion and again considering it is possible to convert, which means my original array had a B, C, D and my changed array had a C, D, E. It is possible to convert with some specific cost. That's true. Only thing I can convert. The condition says that if you are using this conversion, which means you are converting this specific length 4, then you cannot convert this length, any other length which is overlapping with the existing modification which you have done. Which means if I am using this conversion, I cannot use any other conversions possible which is overlapping with this existing conversion. So I cannot use this overlapping, this, or any overlapping whatsoever. I can use this, I cannot use this because it is overlapping. So I can use this as a new conversion and I can convert that to EGH, considering it is possible to convert. But still, even if it is possible to convert my CDEF to a DEEG, even if it is possible to convert this to a this, still I cannot convert it because it is overlapping with my previous conversion. If you want to use this pin conversion, so simply don't use this blue conversion. Use something else. But you cannot overlap your conversions possible. Okay, that's the first condition. Other condition says is, it was the first condition, that you cannot overlap your conversions, right? Other condition says is, if you want to overlap, you can, but it should completely overlap with the previous conversion. It should completely overlap. Okay, the new overlap, I can just use this conversion and say, okay, I converted this A, B, C to, let's say, A, C, D, F, and then I can use the exact same conversion to convert that to a A, C, D, E. That is possible. So two things, either you use an entirely different conversion, else you use some exactly same conversion to convert that to a final value. Okay. So it is the question, what the question was saying. Now coming on back, what we wanted to do, exactly same stuff what we wanted from the solution. Return the minimum cost to convert the string source to target. Minimum cost to convert the string source to target. Now, for sure, I will have some conversions possible, right? I can convert this, I can convert this. So firstly, the first obvious, or basically the first confusing thing, the first obvious confusing thing is, but yeah, how to even know that shall I convert this to this? And for sure, you will, if you have a A, you will convert that to a A, right? If you have a AB, you will convert that to a AC. Like if you have a BC, you will convert that to a CD. So basically, it's just that, okay, every of these characters needs to come to their corresponding positions. That is very obvious, which we saw also previously. But now the biggest issue is, one issue is for sure, one issue is because of these, as the strings rather than characters. One issue is this, which we can handle by using some hash, which we will see. Or let's firstly see that if the problem would have been, okay, if I convert this entire thing, now if I just imagine this as the same problem as the previous problem, and just imagine that you don't have this as the entire strings, it is just one characters. Let's take that example itself. So if we just look at this example, so rather than the strings, let's imagine these are only the characters, right? Only the characters. So I'll just paste this down to just make you feel good, make you feeling good. So you saw that here the problem is exactly same. Convert this character to another character, and this is the cost. Now if I ask you, bro, let's build the exact same graph. So I build a graph from A to B, the cost is 2. Now if I ask you from B to C, let's say from B to C, the cost is 5. From C to again B, the cost is 5. From C to this specific E, the cost is 1. From E to B, cost is 2. E to B, cost is 2. From D to E, cost is 20. So you have built this specific graph, right? Considering although it is a string, considering their characters. Now if I would have asked you, bro, what is the minimum cost to reach from E to B? What's the minimum cost to reach from E to B? Then you would have simply applied the Dijkstras as you did previously. As simple as that, right? Now do the exact same thing when they are strings, right? So you know that, okay, BCD can be converted to a CDE with the cost of 1. FGH can be converted to a THH with the cost of 3. THH can be converted to a GHH GHH with the cost of 5. So this is the graph which you can build. Now if I ask you, bro, from this value FGH, you have to reach to a GHH. What is the cost? What is the cost? What is the cost? Simple, you will say, okay, I'll just apply Dijkstras from this node and I'll do a Dijkstras and we'll get the minimum cost to reach to all the other nodes. As simple as that. Okay, but when I will ask you this specific string, and every time, which means it's a node, right? Node is a string, and this string, which is the, because the original is actually the vector of strings, so it's all our strings, so all of them are strings. And if you go and see, then this original and changed of I consists of only lowercase English letters. Okay, that is great. But if we go and see, the original length is 100, which means this length itself is actually a 100 length. Okay, sorry, 100 length in the length. But every character original length is 100 and length is source length. So source length, it is actually this length. So this is actually less than or equal to 1000. So original of I dot length. So every character, it can be of length 1000, right? But this length itself, it can be of 100. And again, this source, it can be of length 1000. It can be of length 1000. This length, original length, it can be of length 100, where every character is of length 1000, worst case. And the same goes for the changed, it can be of length 100, where the worst case, it can be of 1000. That is, see, to just imagine. Now if I ask you, every of this string can be of length 1000, and you know that you can have 100 edges. So if you will try to go on this, because see, the node, you have to name a node, right? Name a node FGH. For a node FGH, go on to its neighbor, which is FHH. So you saw, I will be iterating on 1000 characters to just get one node, which is overkill. So what I will do is, I will do one thing. I will hash these strings out. So instead of BCD, I will call that as a 0. Right? I'll hash it out. Instead of CDE, I'll call this as a 1. I'll call this as a 2. Call this as a 3. Call this as a 4. So now my graph will be as, okay, from 0 to node 1, the cost is 1. From 2 to node 3, cost is 3. From 3 to node 4, cost is 5. Now, I don't have to iterate on the entire 1000 characters. And I will just be iterating on one integer. So now my problem has become super simple. I will be hashing my strings out and will get the characters from it. Okay, but remember that, okay, for a hash of 0, it represents to a BCD. So I'll just have a hash saying hash of 0 represents a BCD, hash of 1 represents a CDE, hash of 2 represents a FGH, hash of 3 represents a THH, and hash of 4 represents a GHH. So when I would be wanting my strings back, I can just get from this specific hash, right? You can also have it vice versa, BCD to this value, depending upon what will be used later on. But we will have a specific hash from number to a string or from string to number, just to iterate on the graph itself. Okay, cool, no worries at all. Absolutely fine. Now I saw that we will have at max 100 edges. Okay, I will have edges count as at max 100, right? And the same goes, like, I will have at max 100 edges, and the same goes for my vertices. My vertices also, you saw that these are the nodes itself, right? From this node to this node, I can have nodes, different nodes, as if, okay, this is a node, let's say 1, it's at node 2, it's a node 3, it's a node 4, it's a node 5, it's a node 6. So if I have 100 in the original, 100 in the changed, and all are different, so in the worst case, I can have 200 as my vertices. That's it. So it's as simple as that. You can do anything to find shortest path. If you go and do a Dijkstras from every of the nodes, so one thing which you will be doing is, okay, from all the nodes which are actually V, right, you will go and do a Dijkstras which is E plus V log V. That is what you will be doing. And for sure, when I say this, you can just pre-compute this, or as Satvi was saying, we can also use the Floyd Warshall, which will just simply say, okay, it is actually a V cube. And in both ways, we have this value and this value. Both ways, this is actually Dijkstras, Dijkstras, and this is actually Floyd Warshall. Both again, when I say Dijkstras, you again have to pre-compute Dijkstras, right? Floyd Warshall, you again have to pre-compute the Floyd Warshall, right? Okay, with this fact, you will be easily able to get that from a specific node to other node, what is the shortest distance. Okay, this thing is done. Again, edges are 100 because you saw that I will have 100 as the length. If you just come back, my original length is actually 100. This original length is actually 100. So my edges will actually be, in the worst case, will be 100 edges, which I will have. Vertices, in the worst case, I told you it's actually 200. And same, I can apply the extension for Floyd Warshall. Now, okay, this portion is done, that you can find the shortest distance from the string to other string. But coming on back is the main question, from which string to which string you will apply shortest distance. So I can either go and say, okay, I'll apply shortest distance from A to A if it is possible, or I can just say, okay, AB to AB, AB to AC, or I can say that I can apply ABC to actually ACD, or basically this, anyways it can be possible, right? Thus here comes a simple thing. We'll start to think, okay, shall I apply my changing pattern? Basically, shall I apply my transformation? When I say transformation, I easily mean from original to change. It's a transformation incurring this specific cost, right? So shall I apply my transformation on my character 1 or not? Now options are, okay, what length I will think of later, but first option is, shall I apply my transformation on this character 1 or not? No, bhaiya, 1 second. You will have to apply transformation. No, you have transformed this entire string. No, bhai. Maybe the characters are same, so I don't need to apply the transformation at all, right? Yeah, that's true. So for this character, I'll ask, bro, shall I apply transformation on you? Shall I apply? Shall I not? That is what I'll ask him. So now I'm asking him, shall I apply? Shall I not? Shall I not? I'm only able to ask him because he was same. He is same. So I'm just asking him, shall I apply? Shall I not? That is. Now, bhaiya, if they are same, then why in this earth you will be using to apply transformation? You just simply skip it. No. That's a very standard general options which we see, that if we have, let's say, a string source as ABC, my target string is actually ADE, and my original to my what was this called? Original to change has only this string as DE. Sorry, it is only having this string as ABC to ADE with the cost of, let's say, 5. So if you say, okay, I will never touch my A, I will just transform my BC to DE, you will never be able to find your BC to DE as a transformation, and you will say it is not even possible to transform your source to target. But you see that, okay, if you use this, then you can just take the entire thing ABC, take the entire thing ADE, ABC, ADE, that is possible. Cost as 5, okay. That is the cost you can easily transform. So no matter what, even if it is same or not, you will still be transforming your particular character. So at this location, I will ask him, bro, shall I transform you or shall I not? Now if I ask him, bro, shall I transform you? I will. Okay, when I say, bro, shall I transform you? Shall I not? Shall I not? Okay, I'll just simply move to the next character. And I'm only able to say, shall I not? Because these both were same. I cannot ask him, bro, shall I transform? Shall I not? I cannot ask him, shall I not? Because these are not same at all. I have to transform him. I have to transform him. So I cannot ask him, shall I not? Right? Okay, that's true. So it's just a simple DP. Take it, not take it. But here you have to take it, because it have to transform, because you have to convert your source to target. Okay, so here let's imagine for now I did not use it. Now I will come here. I will have to now look for all the options, and this looking for all the options, I have to for every of the index. I'll say, is there way to convert this B to C, or BC to CD, or BCD to CD, or BCDE to CDE, or this entire thing. So you saw that you are at this ith index. At this ith index, you will try for all possible lengths. So I will try for all possible lengths, and ultimately you know that these all possible lengths can be of length n, because it can be this length, this length, this length, this length, this length, this length, and this length. You'll try for all possible lengths. Again, let's say I'm saying lengths. I'm trying for all possible lengths, right? As you saw, I'll try for all possible lengths for this specific index. Now, when I am saying for this specific index, I'll try for this specific length. I'll say, okay, try for a length of 3. Mind, my eyes are closed. I'm saying try for length of 3. When I say try for length of 3, I will have to grab this string of length 3. So grab the string, let's write that down. Grab string of that length. Here are I'll try for all possible lengths, and then when you have tried, then grab the string of that length. So I'll go and grab BCD, I'll go and grab CDE. Now I'll use my map, which is the hash map which I have made. I'll convert this BCD to its number, which is 0. Convert that to a number which is 0. I convert this CDE by using O of 1 operation to a number which is 1. Then I will go and ask my pre-computed Floyd, Warshall or Dijkstras. I'll ask them, bro, what is the shortest distance from 0 to 1? What is the shortest distance? They will give me in O of 1 time what is the shortest distance from 0 to 1 node, right? And this I will just say, okay, the shortest distance is actually, let's say anything. Let's say the shortest distance, obviously shortest minimum cost is C, right? C01. Let's say it is the shortest cost from 0 to 1. C01 is the shortest cost. Then I'll just say, okay, bro, great, well done. I was able to achieve the shortest possible cost. Now you just go and try for this next character. So you can just go and try for this. Now, okay, bro, go and try for, because this is done, go and now try for this specific character, right? Or when I say, okay, I have, again, I tried for this specific length. I'll also try for other length. I'll try for this length also, I'll try for all possible lengths. So you saw that you will go and do for all the indexes. You'll go and try for all the indexes. Every index you will go on. So we have, because the source is of length n, right? This source we saw, it's of length n. It is n is 1000. So it is n, which is actually 1000. Now you will try for all possible lengths. Again, as you saw, it is of length n, right? So all possible lengths are actually, again, n is 1000. Now you will, you will try for the fixed length, let's say 3. You will get that specific string of that length from character I. For that length, let's say t, you will get that string itself, hard-coded string you will get from both source and target, which is again it can be of length n in the worst case. Again, of length n it can have, which is 1000. You will grab that string See, grabbing the string itself is a of n operation because the string itself is of length n. So grabbing the string itself is a length of n operation. When you have grabbed the string in O of one time, you will convert that to their corresponding integer values. In O of one time, you will find the distance between them because of pre-computation, and ultimately you will get the shortest distance, which is simply the CO1, and then you can just simply go and ask your DP, bro, now you can go and try for I plus T, because if this length was T, then you can just go and try for I plus T. You will simply go and say your DP. You see what is the issue in this? Although it is the optimized code, you did some pre-computation, but still it is O of n cube as the time complexity, which will not work because it is 1e9. 1e9 will not work for you. So you have to again optimize it. Now comes the interesting part, which is the most critical, or basically the most hard part of this problem, how to optimize it. Because it's O of n cube, as you can see, O of n, O of n, O of n. Even after doing the pre-computation by using Dijkstras and Floyd Warshall, even after applying DP, still, so we did two optimizations, still it will not pass the time complexity. That is what makes this problem as the hard problem. Now again, if the folks are watching and they are liking this, can you please smash that like button? That would be super great, super helpful. So what we will do is, now we know that we have to optimize it. We will look for what we can optimize. Okay, one thing is that we will have to go on to all the characters. That is one thing for sure. I will go on to this character. I will try for all possible lengths. Then I'll go on to the next character. I'll try for all possible lengths. Now when I say I'll try for all possible lengths, then let's say if I see the length is 3, so or length is 4, so I will grab that length. So this will for sure come, because grabbing that length will be required. One way is I will hash it out. That is another optimization which we can see later on, which may or may not work, because I tried for this optimization, but still it is optimized code, but still it did not work because it has a few other things which was involved. But still we can try to optimize this, which means to grab the string out starting from index I for the specific length T. You have to grab the string out. Now grabbing string out was only and only required because you will grab the string out, then you will convert that string to a hash to their corresponding integer value. What if I was able to directly say, okay, for the specific length I, for this starting index I with the length of T, if I can directly get this node, that is one optimization which we can do, so that we would not be requiring this O of n time. That is one optimization which we have in mind, right? Okay, what else we can do? What else we can do is, okay, if we go and see, we were trying for all possible lengths. Did we use all the constraints properly which were given to us? Maybe not, like maybe yes, maybe not. You see that, okay, you are given the lengths can vary from 0 to, like, from 1 to 100, right? You can have your length vary because see, you know that, okay, your original length itself, number of strings in the original length, it can be 100. So this says that I can have 100 possible different lengths. I can have at max 100 possible different lengths. That is the worst case I can have. So I don't have to try for 1000 lengths. I should only try for my 100 possible lengths. So what I will do is I will just go and find out what all are the possible lengths in my entire original array, or basically a changed array. These will be my possible lengths which I will be needing. With this you will see that you will be able to get, or basically you will be able to achieve, and you will be only requiring 100 different lengths. That's it. So this trying this thing which is trying the all possible lengths was changed to trying at max 100 possible lengths, and that also, like, 100 is the worst case. You just have to go and try, okay, what is the different lengths in your entire original array. In worst case it can be 100, but in the average case it is pretty less than 100. So you will just go and try for all possible different lengths. It can be 100. Now, even if I don't optimize anything, it was 1000. So now it complexity reduced to 1E8. This will pass. This will pass. Now, this was the best optimization which we could do for this problem, which is 1E8 as the time complexity, and this will pass. But this is, you see, 1E8 is just the brim to pass. The test case are designed such that 1E8 should pass. You do anything which is not, which is like, and you do any extra thing, it will start to fail. That is the reason I say that question 4 was hard, because it had a very restrictive time constraints for this problem. Now, coming on to what else optimization we can do. As I mentioned, that the only reason to grab the string for that specific length, and we saw, okay, we can optimize the length. The only reason for me to grab that specific length was actually, now you can see that my friend is calling, but yeah, we will see it later. So we'll grab that string for that specific length. So as I showed you, we are grabbing the string only and only because we have to convert that string to the integer value which we wanted. Now in this, you can use any of the string algorithm, let's say KMP or Ravenkarp, to say, okay, starting from the index I, for this length t, just get me the hash out. Now I will have the hash. Hash is the integer. Integer will not take 1000 space. So integer will not take 1000 iterations, right? Integer will just take one iteration. So rather than getting the entire string B, C, D, E from I for the length of t, I was saying get the entire string B, C, D, E. Now I will say from I, starting with t, get the hash of this string, which I will just which I will pre-compute, and with this pre-computed hash, I can just get this thing. Okay, the hash is, let's say the hash for this BCDE is, let's say 8654, something like that, 5432 is the hash, let's say. So I know I'll just map this hash out to this ID. Earlier I was mapping my string to my ID. Now I will map my hash to my ID, and that's how I can simply optimize this. But again, that will be a part which is the extra part which you can do, which means you will be doing 4 optimizations. One is doing the pre-computation using Floyd, Warshall or Dijkstras. Other optimization is instead of recursion, you are using DP. And for sure, I tried the top-down DP. It will actually go and try for these unnecessary lengths or unnecessary iterations. So it might give you TLE. So we have to go and try for the bottom-up DP. Now, even after we do and try for bottom-up DP, still we saw it will have as 1E9 as the complexity, which will fail. So we will have to optimize something. Then we saw the other optimization was that we can just reduce the length. Okay. If we reduce the length, then we will pass the complexity, which is actually 1E8. Now, for the folks who still want and are more curious to know, other optimization which we can have is, we are grabbing the string for that specific length, which string was also of length 1000. We just have to convert, like we are just grabbing the string just to convert that to a hash. Sorry, just to convert that string to the ID and then apply the pre-computation of the Dijkstras or Floyd Warshall on that specific ID itself. You want to apply. And now now we can just pre-compute that and just have the answer of 1. But to convert that string to my ID, I need to have a map, and for that map, I need the string itself in the first place. So for that string itself, I need to do this 1000 iterations on the characters of that string, which will take 1000 extra time. So ultimately, I can convert this entire string. I can also pre-compute, okay, starting from index I for the length t, what is the hash of the string, which I can do by simply using Ravenkarp algorithm. Now again, that is a pretty complex thing which we have seen. So what we will do is, we can just simply go and solve it in 1E8 time, right, which is nothing but n into some other variable, which is actually nothing but length. So length is actually possible lengths. It is actually 100. This n is 1000, which is the source length. And for sure, applying DP will for sure take this to go on to string. It will take a O of n again extra, and to go on and try for all the possible lengths, it will take the 100. So if you just say it is n into c as the time complexity for this specific algorithm which we saw, which will be 1e8. Considering we are using DP here, we are using Floyd, Warshall or Dijkstras, we are using the pre-computation for it. Pre-computation, which is actually O of 1, and also we have optimized this by using only length, which is actually 100, which is a tricky part to optimize. And also on top of it, we'll use a map, or basically hash map, to convert from my string to my IDs. So with these optimizations, I can simply solve it in O of 1e8 time. Now, to again further optimize it, which I'll say you can try it optimizing. Other optimization which we can do is, rather than this n which we're encountering, we can have a n into c. N is for the DP, c is for all the lengths possible. I know that I will be doing some pre-computation, as in that, okay, we can have this v into e log v as the time, or we can have this v cube as the time. So we can simply add this also plus v cube. V, as you saw, it is nothing but c cube. You can say directly c cube. That is one thing, or you can also say that as it is c square log v, c square log v, c square log v. That's another thing which you can say for the specific time complexity, which is c square log v, or basically c cube. Both will work because both are very less. So in the other optimization which I showed you for using the hashing, or basically using the RabbinCap or Floyd RabbinCap or KMP, I'll say use the RabbinCap because it will hash your strings out. So for the shortest path, we can have a v cube, or basically v e into v log v. It was v into e log ev. It was v into e log v. This is for Dijkstras or Floyd Warshall. Now next optimization which we did was using a DP. DP will have n into some time complexity, which is going on to all the possible lengths and then grabbing the string out of length n. So this will be because of DP. This will be all the lengths possible, which is actually 100. This is actually 1000. And this will actually again be a 1000, but instead of this saying, we will do a pre-computation and we'll go on to the entire string of this length to try for all the possible hashes of this specific length. I know, okay, for the n length, because we know that the source can be of length n, I have to hash all the possible lengths. I hash all the possible lengths. Now to hash all the possible lengths, I'll again and will have to go and say, okay, to hash this length, I will again have to do some pre-computation to hash this also. That's the reason I'm not going into this, but still, just for the some of you who are much curious to know, you are at the string I, you have to go and hash this length t. Then you will go and hash this other length, which is t2. So starting from this I, you will be going on to all the characters up till the end, which is nothing but n into n, right? In worst case, although you will say, okay, I'll try for all the lengths. Length is a mid part, which means length will come inside this n. So that will be O of n into n. So it will be 1000 into 1000. Right? And then, okay, then when this hashing portion is done, you will have some hashing concept, which is some multiplication. That will be O of 1 itself, which is actually hash that specific ith character length t1 or length t2. And you will do it for every character for all these specific lengths. You will go on. So that will be O of n square. So ultimately, if you use this, so you will get a c cube plus n into c plus n square as the time complexity, right? And if you use this, which we saw above, it will be n square into c plus c cube. That will be time complexity for this. That is for this. Cool. Again, that is a super optimized code, which will for sure be pretty lengthy to write, and there are multi-propagation, which means this hashing also, you need to be sure it should not have collision, right? It should not have collision. That is another thing which you will have to take care for it, another optimization which you have to apply for it. That's the reason this question is super, like you saw, it has 5 optimizations. That's insane. Cool. Another thing which you have to make sure, it should not have collisions, because you are using Rabin Carp, which you can simply use a modulo because the lengths are not that big. Cool. The details you mentioned will explaining the time complexity part is very impressive, bro. Thank you so much, Satvik. Now that is pretty much. Again, I will not go into this. I will not go into this entire thing. For sure, you can try it by yourself. I'm not saying, but I'll not go into this because this portion is still, even if I'll write it, the complexity is less. Still, if you will try handling collisions, you are gone. All the collisions are very rarest of the rare case, but still, I'll say that we can right now go again. I'm saying that it is not the most optimized code. You will see it will just pass on the brim. As you saw, it is actually 1E8, which is just passing at the brim. 1E8 is just the end of the complexity itself. More than 1E8, you are just gone. So it is just passing. So for sure, the test cases might in future are designed such that they only and only pass on this. And again, on this, when I say on this as the optimized way, because the way you implement this hashing needs to be as good as possible. For solutions, you can go and look for the page, but most of the people did like this only, and still they got passed. But still, I'm telling you that it is not the most optimized code. The most optimized code is using hashing for the strings itself. Cool. Now let's quickly finally see the code itself. Again, the code was again not from me. It is the top solution of Leetcode itself, because I tried this approach. See, I knew that this would not pass. So I was trying this, and this code became so big and so complex. After trying for 1.5 hours, this solution, I was trying for this solution itself, and I was getting some TLE. I don't know why and how I was getting a TLE for this, but I was getting a TLE for this. I tried something, I got a wrong answer for it, then I lost all the hopes, and then I went on to the solution. Okay, great, well done. And then the cleanest code I could find was of the top solution of Leetcode itself, so I grabbed it. But again, this solution is not the most optimized considering the complexity part. In interview, you can just let the interviewer know about the 5 optimizations, which is graph, DP, pre-computation, which is the pre-computation, which is the graph using Floyd, Warshall or Dijkstras. Again, it's a pre-computation. DP with optimization, which is using only the length. DP with optimization only the length with the pre-computation of the string hashes. Now, string hashes pre-computation, we can use Rabin Carp or our KMP. Now, KMP is better but has more complexity. Rabin Carp is less better because it is actually it can have collisions, but it is still better because it is much more easy to understand and also implement, and also lesser in complexity, but can have collisions in the worst cases. Cool. Now we'll go on to what we are doing. So you see that we will have these labels, as I showed in the beginning also, that I will have to map my strings to actually a node value. So it is a label. It is a label which I am saying label, right? The label which you drink. Cool. And then firstly, I'll just label them out, just simply going on to all of my original strings, because see, as I showed you, this entire hash can be of what length? As I showed you, I can have all of these as the distinct nodes. So I can have a label as 0, 1, 2, 3, 4 and 5, right? I can have, let's say if I have 100 nodes, so I can have 100 into 2 as different labels, maximum different labels. So I just go on to my entire original array, vector. I go on to all the strings in the original vector, and I just say, okay, if this is already not found, just label this up with the current size of this particular thing. So what it is doing is my entire hash, which is the label map, it is having my BCD. My hash BCD is initially like my label map is having nothing in the beginning. So I'll just say, okay, BCD will be label.size. Label size is 0. So my BCD will be mapped to 0. Then I will just push this BCD in my label. So now my label has one thing, which is BCD. Now I'll go on to next character, next string. I'll say CDE. Again, I'll just say label.size, which is, again, now it has one strings. So it is 1. Now it is also pushed in as CDE. So for the next character, which is FGH, I will say label.size. So it is now 2. So incrementally it is increasing. So that is what we are doing. We are just saying, okay, label of that specific string inside my original vector of strings as the label.size. And the same I am doing for my changed. Now, okay, I have labeled all these strings, which means I have labeled all these strings. Right, cool. Now when this entire thing is labeled, I now will make my distance array, because now I need to do this. I need to do this particular pre-computation by either using Floyd, Warshall or Dijkstras. Right, here we have used Floyd, Warshall, no worries on that part, but you can also use Dijkstras. So you did some pre-computation, again distance from these nodes to how you use Floyd, Warshall. How you use Floyd, Warshall from n nodes to n nodes, right? Now these n nodes can be these nodes to these nodes, as simple as that. So you will just go and do the pre-computation. ये सबका कॉल आ रहा है, एक मिनट. ओके जब चले तो कॉल करना. जस्ट एक सेकंड, ये लोग भी जान ले लेंगे. हाँ भाई बिल्कुल, बस 5 मिनट में. हाँ भाई 1 मिनट. अरे भाई ये वीडियो कैसे हो गई. हाँ भाई बिल्कुल, बस 5 मिनट में 5 मिनट में हो रहा है. अरे भाई चल जा ऑडियो. अरे भाई मेरे चल जा भाई, छोड़ मैं लिख ही लेता हूँ. ठीक है. नाउ सो एज वी सॉ, भाई ये कॉल करके परेशान कर दिया भाई इन लोगों ने मुझे. कल से कॉल कर रहे हैं, पता नहीं क्या हो गया इनको. Cool. So just simple thing. What we will do. अरे भाई चल जा, मेरे फोन नहीं चल रहा है तो आजकल. Cool. So the simple thing which we will do is, okay, we can just have a Floyd. What we can apply. We know that we have these n nodes, as we know that we have these hashes as the new nodes values. So these are the labels.size. Label.size is the number of different nodes which we can have. So I just get the distance vector, basically the distance matrix having this as a node. Now I'll just simply apply my Floyd, Warshall. So I firstly have in the Floyd, Warshall, you know that you have your k, you have your I and j. From I to j, you try to minimize the distance between I to j in the k iterations. That is how Floyd, Warshall works. But before that, you also remember that you also have original to changed array. So please also populate your distance array with the first initial values. So my distance array will be populated with the initial values, which is from original to changed. I will have this minimum of this distance from like the distance which I have. I'm just trying to place my original values, which when I say original, I mean from this original to changed, this is the distance. So I'm just trying to place this original values, which means this initial distances in my distance vector, and I'm just trying to minimize my distance vector by this initial values which I have. Okay, I'm just placing my initial values, which is original label to change label, minimum of this distance, and the cost of I. Cost of I is the distance between original string label to change string label. This is the cost, and I'm just trying to minimize this cost, like this distance from my original label to the changed label with this cost of I. I'm just trying to minimize that. So when I have used my initial population to populate this distance, then I can go and apply my Floyd, Warshall. Again, as I showed you, node I to node j having k iterations. As simple as that, which we apply. And when I say k iterations, I to j, I'll try to minimize I to j distance with the I to k plus k to j. That's how this is required, so that you don't have overflow wali conditions. So we actually have to write this down, right? Okay, now I have done the pre-computation also. Now comes the interesting part, which is the DP part. So as I showed you, I will do DP on my, okay, I'll go on to, as I showed you, I'll go on to all the characters, of the DP, but I want all the possible distinct lengths, right? As I showed you, I can have 100 possible distinct lengths, but what all 100 lengths, right? That is the case for us. So I'll iterate on this original array and will grab what all possible distinct lengths are there. So I'll just iterate on this original array and I'll grab all possible distinct lengths. Okay, substring lengths are the all possible distinct lengths which I can have. So I'll just iterate on the original array and I'll get all possible distinct lengths which I can have. Now when I have gotten all possible distinct lengths, now I am good to start my DP. Now as usual, you will just have your DP vector. Let's forget this case right now. If it is same, you'll just say, okay, minimize the existing, like minimize the values, which is the next value, because see, how this DP is applied is, you have let's say you take the same string, which we have pasted above. So see, that's the reason bottom up DP are a bit tricky to understand. So we are saying, okay, if the ith character is same, then I'll just say, okay, I plus 1 is actually containing, okay, go and try for I plus 1, and I plus 1 I will minimize. If the ith character is same, I'll go and say I plus 1 value I am minimizing. Now if let's say I am at this character I, right, I will say, okay, this length was okay, then okay, length is t, length is 3, so I'll just say I plus 3 length. Okay, I can just minimize that I plus 3 length. So on every I character, let's say the ith character was this, when this is okay, or when this is done, I am trying to say, okay, DP of I plus 1, I will, because by default it is infinity, but I will just try to minimize that DP of I plus 1. So basically your answer is being stored at the next character or next index. So for up till the ith, your answer is stored at I plus 1. So up till this end, let's say the indexes, if I just name the indexes, which is actually ID is 0, 1, 2, 3, 4, 5, 6 and 7. So answer will be stored at the last 8th index. So if I have reached here, so for sure my answer, because answer as an answer will be stored at DP of this, which is the length is itself, the length is, let's say, 8. So answer will be stored at DP of 8. If this is same, I'll store the answer at DP of 1. If this is same, I'll show the answer at DP of 4. If this is same, I'll show the answer at DP of 5. If this is same, I'll show the answer at DP of 8. This is how it is being working. Cool. So if this is ith character is same, I'll show the answer at I plus 1. So minimum of I plus 1 and DP of I. Cool. Now I'll try for all possible lengths, as I showed you. I'll try for all possible lengths. Again, if the length exceeds the string size itself, so continue. Else, go and try the source string, go and try the target string of these lengths. Okay, these are the lengths. Starting from the ith index, this is the length. Ith index, this is the length. When you just grab this, just go and ask, bro, for this specific string which you have gotten from the source, was a label for it. If you have a label for it, which means you had, okay, if you had a label for it, okay, get what was the label for it. Else say it is -1. If you have a label for that specific string, which means for this specific string, if you have a label for it, and for sure if you remember, you had a label for it, BCD, you had a label which is 0. So get that label itself. Okay, I'll get the label which is 0. Here also for the substring, I'll get the label. So if I go back for this target string, which is CDE, I'll get the label. Label is actually nothing but 1. Okay, again I've got the label which is C2. Now when I've got the label, which means both the labels are not -1. Both the labels are not -1, which means I have label for both of them. And also the distance between both the labels is also not infinity. Then I can say I can easily have the cost from here to here, that is possible. Then update, if this is the ith index, update the I plus t, dp of I plus t. So I'll do the same stuff. I'll update my dp of I plus t with the minimum of dp of I plus t with the dp of I, with the dp of I, dp of I with the cost, as is simple to win a dp, right? It's just that you are updating your dp of I plus t when you have found the length t itself, right? Cool. And ultimately you will just keep on repeating for all the possible lengths which you can have, and that is a 100 length, worst case. In worst case you can have 100 lengths. Then you will try for all the possible indexes, right? When this entire thing is done, as I showed you, your answer will be stored at this, which is dp of 8, right? If the length was your target dot size is the length, target dot size is the length. So, and the length was 8, it is a target size, so your answer will be dp of target dot size, right? Target dot size. So I'll do the same thing. My answer will be dp of target dot size. If you see, the dp of size is my target of length plus 1, so minus 1 will be target dot length only, target dot target dot length only. So it is nothing but, I'll say it is dp of target dot length. And if it is a long max, simply return a -1, else return the target dot length, because that will be storing our final answer, and that's how you can simply get the answer. Again, the only interesting part for this code is your answer is being stored at I plus 1th value. So ultimately, final answer will be stored at dp of the size, which is the target dot length, right? If it is same, you store the answer at I plus 1, as you saw. If the ith index is same, you store the answer as I plus 1. If the ith index is same, you store the answer at I plus 1. That's it. Cool. And if it is infinity, which means you are not even to possible, like it is not even able, you are not even able to reach that location, simply continue. Again, this is the entire code for it. Again, this is a very hard problem. I'll say very hard problem. It's very hard to come up to this solution. Even if you come up to it, implementing it is super insane. So yeah, that is how we can actually solve it. Cool. Now we quickly have a chat read. Any question whatsoever you have, you can just comment down below. Okay, video is gone. Why? Video is gone. Hello, why the video is gone? Cool, no worries. We can have the video from here itself. Hi. Maybe the battery died. The details you mentioned were explaining, it's the DC part. The time complexity for Rabin-Karp algorithm for it is to go and find the hash for all the substring. It will be O of n square, which is the length. If the length of the string is n, and you have to go and try find the hash for all the substrings, it will be O of n square. Cool. If you have any other doubt, just quickly mention that, else we'll be ending the stream, and I have to get some calls done because people are calling continuously. Cool. Thank you so much for watching, and before going, if you can please smash that like baby to just 35 likes, that would be super great. Although yeah, I know that's my mistake. I could have done the stream in the morning itself, but I could not because I was in shock that my live got started automatically. Cool. Thank you so much for watching. Any doubts whatsoever? No? If yes, then you can still comment down below. I'll be very happy to answer them. But it was a very tricky question. Cool. Thank you so much for watching. Bye, goodbye, tata. यार ये बैटरी खत्म जल्दी हो रही है आजकल. I don't know why, but yeah, cool. Thank you. Bye bye. Any doubts, you can still comment down below. I'll still be happy to answer those. It's super large. Cool. Bye bye.